Hello, sir. Now we want to explain the binary PSO case for IEEE 10, and after that the other cases, but it is the same. As you see here, we have the line data, the line data, the load flow program, the PSO case, the mini program, and the PSO program, and the base voltage. This is the data. If you open this file, it is the output voltage profile from the base case. We put it here to compare, and the line data the same thing as you see here, and the load data it is the same before, and the main program it is the same, but here now it is the first thing we call the binary PSO code, and after that the output from the binary PS code it is put it in the load flow to calculate the result as you see here, and the preparation, the generation after get it this value, we will preparation the distributed generation, the capacitor size, the location of distributed generation, the location of the CP, and then printed the result. The result it is the size of DG, the location of DG, capacitor size here, and the location of the capacitor, and the fitness value that we get it from the binary PSO. And then after that the network result, power losses, reactive power losses, voltage profile, reliability index, energy not supply, and the minimum voltage. And then after that we call the calling here the base voltage profile, and then printed in the same graph the voltage of the voltage of the network after compensation, and the voltage before the compensation to compare between them. This is the main program, and as you see here now, if you go to the explain the load flow, what is the change in the load flow? Now the load flow it is we have the input, not like the base case. The input that it is contain the size of the distributed generation, the size of the capacitor, the location of distributed generation, the location of the capacitor, and then as you see here we add it to the real power of each bus, real power of the buses dependent on the location as you see here of the distributed generation, and also the capacitor size on the buses that dependent on the location that program optimized or put it as an input. And then we repeated the power flows, the same thing, calculated the voltage current, and the same thing, all the thing, and then we calculated the losses, and after the losses and the power flows and the voltage profile index, and after that and reliability index, energy not supplied, and then after that we calculated the object function. It is the fitness value. It is dependent on the reliability index, the power losses, the reactive power loss, and the size of capacitor and distributed generation size, and the cost of size. And after that we printed that or out that from the load flow. This is the load flow. This is the difference. Two things. It is the preparation, the capacitor and distributed generator size and location, and calculated the object function. It is this is the difference, only the difference between the previous one and the now of the optimization. In the next video we go to the explain the PSO program itself. We hope it is clear for you, and if you have any question you can ask us, we will help you.